morning one and all. I am Dr. Ramya Swetha, Assistant Professor from Department of Civil Engineering, Institute of Aeronautical Engineering. Today our topic is overall summary of the ground improvement techniques. In this lecture, in the previous lectures, what we understand, what is meant by ground improvement techniques, what are the various techniques which are going to involve for improving the soil properties, enhancing some properties, and it depends upon depends upon which situation, what kind of enhancement or desired property of the requirement of the soil for construction work or different projects. These are all the things which we are going to understand till this class. So now this is the overall summary about the ground improvement techniques. How we understand these ground improvement techniques, how we encourage the techniques for getting the better results, choice, the suitability of the soil, based on that suitability and the requirement of the construction work, choice, which technique gives better results, better outcome, and it may be and different number of techniques are available for that solution, for that problem, or for that whatever the required desired property, what we required for ground improvement techniques. As a part of ground improvement technique, we may choose n different types of techniques for getting the better enhancement based on some, for example, some properties, stability, strength, and safe bearing capacity, like this, and different properties are there. Plasticity, we may reduce plasticity, permeability, like this we have and different number of soil properties. For that, for getting the desired limit of that property, for getting better construction work, sometimes it may enhance, sometimes in some of the properties we may reduce. So it depends upon the required construction work. So based on the required construction work, in which limit that particular property, some X property or whatever the various properties, how we will get using the techniques. For each property, n different number of techniques are may available. So and different techniques according to the property and according to the required structure, what we are going to construct there, as per the element requirement, we are going to choose the or which one is suitable for that construction based on again different characteristics. So either maybe based on the construction work, based on the material availability, cost effectiveness, economical point of view, socio point of view, in sometimes environmental impact point of view. These are all the various parameters which we are going to understand in this ground improvement techniques. So it is going to combination of n different number of techniques. They are going to enhancing the physical properties of the soil to make sure they are going to for construction purposes. So it may be building construction, high-rise buildings, at the time of foundation we require, or below the groundwork, what are the various kinds of elements we are going to done for that project work. These are all the parameters, and where we are going to construct that thing, whether they may be sandy soils, silt soils, clay soils, or hardened soil, fine grained soils, coarse aggregated soils are they may be presented there. It depends the combination, and also different types of environment, nearby huge structures are there, or sometimes it may be different kinds of environmentals are there. These are the things which we are going to understand in our ground improvement techniques. So in this we are going to enhancements including strength, reducing compressibility, and improving drainage capabilities. These are the various parameters are going to enhance using this ground improvement techniques. So in ground improvement, it is crucial we are for ensuring the stability and longevity of this structure, such as buildings, highways, railways, dams, airports, mining, tunnels, different kinds of environmental, different kinds of structures we are going to, especially in areas with poor soil conditions. We are concentrated on the poor soil conditions, and also we are enhancing the physical properties of the soil to make it suitable for construction purpose. So this is the importance of the ground improvement techniques. In generally, what are the situations requiring for these ground improvement techniques? It may be the weak or compressible soil, high groundwater level, special construction requirements. These are the cases. These are some of the cases which we are going to observe in our as a process of ground improvement techniques. Also, in some of the situations, there is no other kind of option for that project. Yet weak soils or compressible soils, we are going to construct a huge structure or dams or tunnel, whatever mining we are going to conduct in that particular area. It is high risk for that construction work. In that particular situation, we are going to choose the techniques which are giving the desired properties for better construction work for the particular project. So in that particular, we are facing these kind of weak or compressible soils. So in these areas with soft clays or loose sands, require good environmental to prevent excessive settlement. In that particular regions, once we are going to construct or design any huge structure, in that particular situation, we are going to, there is a excessive chance of settlement, and it may lead to the potential failure of the structural failures may happen. So in that particular situations, we are going to use these ground improvement techniques for to reduce the settlement foundations and also strengthen the particular structure. So in these weak or compressible soil, we are going to understand, depends upon the type of the soils, we are going to conduct basic tests for understanding the soil properties, and also as per the design requirement of the construction work, design requirement. So these are the parameters which we have understand for choosing the best ground improvement technique. And also next move on to the high groundwater levels. So in ground improvement techniques like dewatering and drainage are necessary to manage the groundwater effectively. These two are the important techniques whenever the high groundwater levels are there. So in below the ground, in some of the regions, the water table is there in anywhere, but they are maybe affected, may not affect the construction work. In some of the regions, the groundwater level is, the water table is near to the ground. In that particular conditions, whenever we are going to construction some project, in that we have to understand the level of the water table and how the movement is there, the way of the movement of the groundwater. These are all the parameters which we are going to understand in our high groundwater levels. So based on the depth of the water level, how much construction work is going to conduct below the ground level. These are all the parameters which we are understanding clearly, and we are going to choose the technique. Those techniques are in like dewatering and drainages. So they are giving the better understanding about these groundwater levels. Next one is the special construction requirements. So in projects, they are going to needing reduced settlement, increasing bearing capacity, or improved slope stability. So in such cases, there are some special requirements of the construction work also. Even the soil is good, the groundwater level is not that much, depth is not there, everything is fine. Even though the project demands reducing settlement and also require the strength, we are going to require more strength. In that particular cases, we are choose some ground techniques for getting this increased soil bearing capacity and also improve the slope stability and reducing the settlement. So in these are all the situations which are required for this ground improvement. And overall, overall overview of various techniques. They are maybe mechanical, hydraulic, chemical, physical and reinforcement methods are employed based on the soil type. So it depends upon the which type of the soil and what the project needs, what are the surroundings and environmental impact and also the cost considerations. These are all the things which we are going to understand. This is the overview for choosing the which type of ground improvement technique is suitable for that construction work. So like this we are going to understand the situations which are going to occur in our ground improvement technique situation. So in ground improvement techniques, the one is the coming to the mechanical modification. In mechanical modification, they are going to understand the compaction. So in this, the principle of compaction involves mechanically increasing the density of the soil by reducing the air voids. So in this compaction, which we are going to involves mechanically increasing the density of the soil by reducing the air voids. So whenever that compaction is there, it may lead the improved strength and stability. The effectiveness of the compaction depends upon the soil type, moisture content and the energy applied during the process. These are the parameters which we are going to impact the effectiveness. The effectiveness depends upon the soil type and moisture content and also the energy how much we are applied during the process and skill also. These are the things which we are going to understand in compaction. Different types of compactions are also there. So those are static compaction, dynamic compaction, vibratory compaction and impact compaction. So in this static compaction which we are going to achieve by the applying steady pressure using heavy weights. Such type is nothing but static compaction. In dynamic compaction, it involves repeatedly dropping heavy weights from a height to compact the soil. In vibratory compaction, we are going to use vibratory equipment to rearrange the soil particles and increase the density. So the main motto of compaction is density, to reduce the air voids for getting the strength and stability. So in impact compaction, repeatedly drops a weight onto the soil to compact it. So these are the various types. Which type is suitable depends upon the requirement and also the type of the soil. So based on that we are using this mechanical modification. For this mechanical modification, for conducting all these various types, we require some equipment. Those are rollers and hammers and vibratory plates. So in rollers also different types are there. Smooth wheel, sheaf foot and pneumatic tied rules, and it depends upon the situation and the soil type. So different soil types chooses the different type of roller. So it depends upon the which type of compaction we require, which method we are following. For that we are choosing the equipment also. So in rammers, handheld or mission operated, ideal for small areas and confined spaces. In small areas, whenever the confined area spaces are there, we are using this kind of rammers. In vibratory plates, they are effective for granular soils, areas which is limited access. So these are the things. Whenever we are choosing the method, based on that we are choosing the equipment to get the compact. In field applications and quality control, applications in road construction, we are using this type of compaction in road construction and also the foundations, embankments and landfills. These are the various project construction work. They are going to involved in this such type of mechanical modification is required for getting the desired soil properties. And depends upon the project we are choosing the equipment and also the method of the compaction also. In quality control through field density tests like sand cone test, and nuclear density gauge and protector test to ensure proper compaction levels. For getting the better compaction levels, we choose these kinds of tests like sand cone, and these are helpful for understanding these. And also we are going to quality control point of view also. These tests are to ensure the proper compaction levels. In preloading and surcharging type of mechanical modification we required. In this, the concept, the name itself tells this preloading and surcharging. The preloading involves placing a temporary load on the soil to reduce settlement. So here we have preloading, which are going to involve placing a temporary load on the soil to include settlement and consolidate to the soil before construction. Before construction work is going to start, at that time only the preloading involves placing temporary load onto the soil to induce the settlement. Such type of concept is involved in this preloading. So before the construction work is going to start, whatever the settlement and temporary loads they are going to place involving this preloading. In surcharging uses additional load to accelerate the settlement process. This is the one type of mechanical modification. In this preloading process, increase effective stress in the soil, accelerating the consolidation and reducing post-construction settlement, often combined with vertical drains to expedite the process. In real world examples for these preloading and surcharging are highway embankments, airport runways, and large building projects that have successfully utilized preload and surcharge. So in airport runways and highway embankments, these kind of mechanical modification is required. In dynamic compaction, the process of this dynamic compaction, we are using cranes to lift and drop heavy weights. So the weights, whenever compaction we are draining, those comes under static, and we are using the rollers and hammers and vibratory plates. But here we are using cranes to lift and drop heavy weights onto the ground, creating shock waves that densify the soil. We are creating the shock waves that density of the soil. These kind of dynamic compaction we are using, improving the loose fields and land accumulation for granular soils. This dynamic compaction is effective. In limitation include high energy requirements and potential disturbance to nearby the structures. It affects the nearby surroundings. Whenever we are using heavy cranes for dropping the weights from some certain amount, from 10 to 30 meters from weight we are dropping, means it may affect the nearby structures. Nearby any small structures are there, they are going to affect. So this is the major disadvantages whenever we are doing in rush areas, or heavy nearby construction work is there, nearby houses are there, nearby environment is going to affect because of this dynamic compaction. The case study, it is useful for the industrial foundations, port constructions, such type we are going to choose these kind of mechanical modification, that is dynamic compaction. But this, we be cautious about the nearby structures. It is going to disturb the potentiality of that particular structures. So in this we are using for industrial foundations, port constructions, and also we are going to reclaim the land projects, demonstrating the benefits and challenges of this dynamic compaction. Next one is the hydraulic modification. So in hydraulic modification, that is nothing but the water. In hydraulic point of view, we are going to reduce the moisture content. Then that gives the properties which are required for the construction work. So in dewatering techniques is one of the hydraulic and important modification which we choose for reducing the water content in the soil. So this is the one of the technique we follow. In this, well points, deep wells, vacuum dewatering are there. So well points, deep wells, vacuum dewatering are the various techniques under the dewatering technique for hydraulic modification. In this hydraulic modification, small diameter valves connected to pump to lower the water table around an excavation. Such type of technique is known as well points. So smaller diameter wells connected to pump to lower the water table around an excavation. In deep wells, larger wells that reach deeper aquifers for significant dewatering needs. In vacuum dewatering, we are using vacuum pressure to extract water from the soil suitable for fine grained soil. So it depends upon which type of technique is suitable for different kinds of types of the soils. It depends upon the type. So based on the type, we are choosing the technique. For fine grain soils, we are choose vacuum dewatering to extract water from the soil. So we use different kind of equipment also for this dewatering. Pumps, headers, discharge systems and monitoring equipment we are using for this dewatering. So applications in construction excavation, basement, underground structures and mining operation are the major projects which we are going to use this kind of dewatering technique. Which type of dewatering technique we are choose depends upon the type of the soil. So coming to the case studies, we may understand the detail from construction sites in high groundwater areas, and also for high groundwater areas in some of the basements or underground structures. That is helpful for better understanding about this technique. And also other technique is drainage. Vertical drains, horizontal drains, different types of drains are there for getting this dewatering. These hydraulic modification we are using different techniques. That is drainage. In that one is drainage. In that again different types are there. Those are vertical and horizontal. In vertical drains, sand drains and wind drains techniques are there for giving the better soil improvement or desired properties for the construction work or the project. So in these sand drains, boreholes filled with sand to shorten the drainage path and accelerated consolidation. So boreholes filled with a sand to shorten the drainage path and accelerated the consolidation. In weak drains, prefabricated vertical drains installed to facilitate rapid drainage of pore water from soft soils. So these are the two techniques which we are used in vertical drains. Moving to the horizontal drains, installed in slopes and embankments to remove water and improve stability, used in conjunction with vertical drains for comprehensive drainage solution. So this is the techniques we are used in under drainage for hydraulic modification for better getting the soil properties. These kind of techniques, these sand drains, wing drains or horizontal drains, we are widely used in soft clay deposits and also slope stabilization, land reclamation. It is effective in reducing the settlement time and improving the soil strength. So these are the techniques which we are used for hydraulic modification. Coming to the chemical modification. In chemical modification and different types of chemicals or admixtures they are going to involve. It depends upon the soil type, project or construction requirements, and how the chemical is going to react with particular soil. These are the parameters which we are going to induce in this chemical modification. The one is lime stabilization. That chemical reaction and soil properties improvement based on the lime. Lime reacts with clay minerals. It reacts with clay minerals to form cementitious compounds. It means they are going to reduce the plasticity and increasing the strength. This kind of chemical reaction is suitable for fine-grained soils with high plasticity. So whenever the soils with high plasticity, we are choosing this kind of chemical modification, that is lime stabilization technique. These application techniques are mixing lime into the soil using mechanical mixtures and compacting the treated soil to achieve desired density and strength. So for different case studies, we are choose this chemical modification, that to lime stabilization, that is for roads upgrades, airfield, foundation projects. These are going to effective of lime stabilization. In another one is the cement stabilization. The chemical reactions and soil properties improvements as per the cement stabilization. Cement hydrates to form bonds between soil particle, increasing strength and stability, effective for a wide range of soil types, especially granular soils. For granular soils, this kind of chemical modification is required, that is cement stabilization. In this, mixing cement into soil, adding water and compacting the mixture techniques include deep mixing, soil cement columns and slurry trenching. These are the techniques which we are going to use in this cement stabilization. In this, projects involve pavements, foundations, embankments and retaining walls that have successfully utilized these kind of cement stabilization. Other chemical stabilizations are also helpful for us. Those are fly ash, bitumen, chemical grouts. So these are the other different kinds of stabilizers which we are used as a part of chemical modification. In this fly ash, it is a byproduct from coal combustion used to improve soil properties. Reacts with soil minerals to form stable compounds. Bitumen is used for stabilizing roads and pavements by creating a flexible and durable layer. In chemical grouts, various chemicals injected into the soil to form a soil mass. It depends upon the type of the soil, and choose a chemical which is suitable and their properties, how it reacts with the particular soil and the whatever the construction we are doing. So for that construction, how it reacts, these are the parameters we have to consider for this chemical grout. So it is injected into the soil to form a soil mass, improved strength and reducing permeability. These types include silicate and different kinds of grouts they are going to include in this chemical grouts. These are going to apply, depends upon the soil type, project requirements. Any kind of technique we are going to choose depends upon the soil type as well as the project requirement and environmental impact. So limitations include cost. For chemical modification, whatever the chemical we are used, it is cost, and also environmental concerns, how it affects the other grounds and nearby. So these are the environmental concerns we have to understand whenever we are using these kind of chemical modifications for getting the desired soil properties. The potential long-term stability issues also. So the durability studies are also important whenever we are using these kind of chemical stabilizers. Physical modifications, thermal modifications, ground freezing. In some of the situations, thermal modifications are helpful for getting the desired soil properties. In that particular, circulating refrigerant through pipes to freeze soil, creating a solid and impermeable barrier. So effective for temporary support in tunneling, shaft sinking and groundwater control. For that particular, we are choosing these kind of thermal methods. So these kind of thermal methods we are going to use in tunneling, mining and excavation projects. In this also we have some limitations. Those are, it include high energy consumption. So because for freezing the soil throughout the pipeline, it depends upon the length and diameter of the pipe also. For continuous energy, energy consumption, high energy consumption is required. So this is the one of the limitation which we understand, and also it's costly and potential and also the potential settlements also. These are the physical modifications. And also soil heating in as a part of thermal modification, soil heating used to improve some soil properties by drying or altering the soil structure. So for changing the soil structure also, we are getting some of the required properties. In that particular case, we are choosing the soil heating technique. So in these applications in cold regions and for specific soil types requiring this thermal treatment. Grouting techniques. Permutation grouting, compaction grouting. In these, injecting low viscosity grout into the soil to fill voids and improve strength, used in sandy soils and for underpiping existing structures. Compaction grouting, injecting thick grout under pressure to compact surrounding soil, reducing voids and increasing density. So application include foundation strengthening, sinkhole, remediation and seismic retrofitting. So these are the compaction grouting. So these are the grouting techniques. And also the jet grouting is also one of the important grouting technique which we are used at high pressure jets. We are using high pressure jets to mix grout within on-site soil or in situ soil, creating soil cement columns. Effective in soft soils and for excavation supports. Techniques including single, double and triple fluid systems. In this jet grouting, we are having different types, that is single fluid system, double fluid system and triple fluid system. In detail, we discussed these kind of systems in our previous lectures. Coming to the applications and limitations, grouting techniques are versatile and can be, there cannot be confined. They are versatile and also to specific soil conditions and project requirements. And also it is going to cost because of the high pressure jets and whatever we are creating the soil cement columns, those materials, everything is going to cost. It is cost and also equipment complexity and potential environmental impacts are also there in this jet grouting. In biological methods, different types of mechanisms and process we are follow for this microbial include calcite precipitation. In this mechanism, utilizing bacteria to participate calcite, binding the soil particles together and enhancing the strength. Environmental friendly and sustainable technique, these kind of method. So they are going to use it for erosion control, dust suppression, soil stabilization and foundation implementation. So case studies, when we are consider some case studies under demonstrate successful applications in various geotechnical projects. In whenever we are going to demonstrate the particular structures without affecting the soil, these kind of biological methods are helpful. Reinforcement techniques. In these different types are there, that is geosynthesis. In this geosynthesis, geotextiles, geogrids and geomembranes are the various types for these reinforcement techniques. In geotextiles, permeable fabrics used for separation, filtration and reinforcement, made from synthetic fibers like polyester. Moving to the geogrids, grid-like structures used for soil reinforcement, increasing tensile strength and stability. Geomembranes, impermeable members used for containment, lining and barrier applications. In these functions, they are going to separation, reinforcement, filtration and drainage are the functions which are going to involve in this technique. So to preventing the mixing of different soil layers maintaining layer integrity. That is the one of the function, that is separation. It move on to the reinforcement. It increasing soil strength and stability by providing tensile reinforcement. In filtration and drainage, allowing water to pass while retaining soil particles, improving drainage and preventing the soil erosion. Such kind of application we are using and installation techniques used in road construction, retaining walls, embankments and erosion control. So installation involves proper placement, anchoring and overlapping of geosynthetic materials. These are the functions we are going to use for this particular technique. Soil nailing. In soil nailing, it is installing the steel bars into slopes to provide stability and prevent landslides. Such type, whenever you are using those soil steel bars, used in excavation support, slope stabilization, retaining walls and tunnel portals. And also some design considerations are there. That's nail length, including factors nail length, spacing, inclination and load condition, soil properties and project requirements guide the design process. For example, for complete understanding about the soil nail, we may consider some of the case studies. In that, one is the highway cuts, steep slopes and urban excavations, showcasing the effectiveness of the soil nailing. Reinforced earth structures. In this, the concept combining soil with reinforcement elements like strips or grids to create stable structures. So, types include reinforced soil walls, embankments and slopes. In this design and construction, design involves selecting appropriate reinforcement materials, determining layer thickness and ensuring proper compaction. Construction follows a systematic approach to placing reinforcement and compacting soil. Used these kind of reinforced earth structures, technique, ground improvement technique used in retaining walls, bridge abutments, steep slopes and embankments. Case studies we are considering highlight the successful implementations and design considerations. Innovation techniques. In these ground improvement techniques, such kind of innovation techniques are there. Those are electrokinetic stabilization. In this, electric current to soil improve properties by altering particle arrangement is the principle involved in this electrokinetic stabilization. It enhances the strength. It is used for the dewatering, contaminant removal and soil stabilization. So in this equipment and the process, it involves placing electrodes in the soil and applying an electric current, monitoring current of flow, soil response and improvement of effectiveness is crucial. This in detail lecture is available in our previous lectures, videos. In case studies, example from contaminate site remediation, soft soil improvement and slope stabilization projects are the case studies we may understand using these kind of electrokinetic stabilization or innovative technique. In vacuum consolidation, it is using vacuum pressure to accelerate soil consolidation by reducing pore water pressure. Effective for soft clays and organic soils. Such kind of vacuum consolidation required equipment and its process. It is installation of prefabricated vertical drains and vacuum pumps. Monitoring of settlement, vacuum pressure and soil improvement. This is involved in this vacuum consolidation. In this, we may consider for examples from port construction, land accumulation and infrastructure project demonstrating the effectiveness of vacuum consolidation. These are the summary of the key points. The ground improvement is vital For ensuring the stability, durability of soil, engineering projects, a variety of techniques are available. It's suited to the specific soil conditions and the project requirement. Emphasize on the importance of selecting the appropriate technique based through the understanding of the soil project needs and environmental consideration. In future trends in ground improvement techniques, development of new materials and techniques to improve efficiency and sustainability. So increased focus on environmental friendly and sustainable solutions. Integration of advanced monitoring and control systems to enhance the effectiveness of ground improvement techniques. These are the textbooks we may follow for these ground improvement techniques. These are the web references we are going to understand the ground improvement techniques. These are the overall summary. So whenever the soil requires desired properties to get the better constructions for project based on the project needs, we are giving the desired properties to the soil using these kind of various techniques. Which type of technique is suitable? It depends upon the soil type, soil desired property of the soil and project requirement. So based on that we are choosing the method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.